My name is Dr. Augustine Wajana. To participate in today's exercise, you should have completed the activity covered in my previous video, which I entitled Basics of ADS Schematic. The video is available on my YouTube channel, so you can just have a look if you haven't covered that activity because it will help you to progress seamlessly in these activities we're going to cover today. Now, for today, we'll be looking at how to use the circuit tuning functionality of ADS. So in ADS, there's a tuning functionality. So today we'll be looking at how do we utilize that functionality in ADS. So to do that, we need to tune circuit components. So we select a few components in a given circuit, tune it to see how the parameters will change. And then, of course, we observe the results of our tuning to see how effective that functionality is and how we can use that to optimize our design circuit. So to get started, all we need to do is go back to our ADS. So we need to launch our ADS as we did before, just ADS. Here you can see again, I'm using ADS 2022. As I mentioned in my previous videos, you can use any ADS from version 2011 to present. So any version from 2011 to the current version should be able to help you complete this activity. So we launch ADS. Okay, so as soon as we get to the screen, what we need to do is launch the activity we did last in the previous video where we looked at the basics of ADS schematic. So well, you can see that my ADS is saying that my license will expire in 30 days. So I still have 30 days to use this. I'm just going to close that window. Okay, now we are in. So we need to locate design I made in my previous video. So that was test spam path filter one, if you remember. If you haven't seen that video, please, you are encouraged to look at that video because it will help you to easily get to what we are doing today. Now that I have this workspace, I've opened my workspace. I can now double click on the schematic circuit. You can see here that this is a circuit that we designed, we simulated in our previous video. So this circuit is what we are going to tune today to get what, for us to be able to appreciate the tuning functionality that is available in our ADS schematic software. Now, so once we have this window open, next thing we do is to go back to the workspace and also open the data display window, which is the results. So we need to have both screens in view. So I need to minimize this window and of course minimize the other. We place them side by side. So the schematic window is also there. So I need to place these two windows side by side. So I can have a clean view of both. So I do this. So I try and get both videos in view. Okay, so that's a bit more. All right, so you can see now that I have the two videos, the two windows I'm going to be working on. Let me just try and get it more in focus. Okay. Okay, so I have this now. You must have this the two windows in view because the idea is when you tune the parameter the circuit, you need to see it change in the this data display window. So that's why we need to have both windows open. Okay, so now there's one more window we need the next thing we need to do here is to now go straight to the tuning functionality. So what icon do we use to tune? If you look at this icon here, if you follow my mouse pointer, you see that this says tuning. So that is the shortcut to arrive at the tuning functionality. So all I need to do is click on that um click on that. Now with with this selection, you need to choose the components you need to tune in this window. Now for today, I would like us to tune the capacitance in the PLC. So I'm going to select the capacitance. Notice that as soon as you select the component, um, you see a slide appear in the tuner. So that's basically where we need to tune the value of that capacitance. Now, the next thing I need to select, let's also tune the inductance value in the SLC. So you see, each time you select a component, a parameter here, you notice that a slide bar is added to the tune parameters window. Okay, so each time you select select another component, another bar will be added. So that's how we perform our tuning. Now, once I've done that, next thing I'll do is to also try to arrange this. We will need to see. I can minimize this one because this is of no use. I can minimize this. Now I need to see um, this bit as well. So I have all of this in view, the three windows in view, because I'll need to be making my tune on this. And of course, I'll have the result displayed on the other display window we have here. So what do I do next? Just now, next step is to tune. Now, looking at these parameters, you see that if I move, just watch what happens here. As soon as I slide, look at the result. You see, once you start sliding this button here, you see that your result changes. The same thing if I slide this bar, or you can just use the up and down arrow to move, and you realize that the result will change as you change the value. And you also see that the values are actually being shown at the top here. So we can go back to what we had there, 27.1. So you can see that if I go back, just play with it until you achieve a result. Now, notice that the values are actually jumping. So the step size is huge. You can see it here. The step is 2.7. So what I will advise you to do is to change the step size. I'm going to change it to, let's say, 0 0.2, for example. And I'm maybe also change this one to 0.2. So the idea is when you click on the up or down arrow, the movement will be in very small steps rather than jumping with a huge step. So that's what I have. Now, if I go back now, you see that each time I click on this button, the movement is not as as profound as it used to be before this test. So you can change the step size, which will help you tune your circuit in smaller steps to achieve the result that you're looking for. Now, let us do something. Let's try and move the center frequency that used to be in. If you remember of our design, I'm just going to go back to the window. If you remember the design that we had, you can see here that that the center frequency our previous design was at 2.6. So you can see here the center frequency is at 2.6. So I would like to move the center frequency from 2.6 to 2.7. So I would like to do that using the tuning. So the idea is you've designed the circuit. You don't want to start all over. You can use the tuning system to achieve a desired result or to fine tune the circuit. So what I need to do now is I'll go back to my ADS window here and I start tuning until I move this up to 7. So I can tune it in different direction. Make sure you retain the return loss at 20 dB because that is our target. We have to retain the return loss at 20 dB. So I will keep tuning. If it means reducing my step size to 0.1, I will do that until I get my target. So you see here, okay. So you notice that each time I move, um, just keep tuning. Okay, okay. Now, so look at the circuit now, it's now at 2.7 frequency. Now, don't forget, you can do anything with this. The idea is to tune the circuit until you achieve a desired result. So we are not trying to achieve anything particular today. I'm just trying to show you how you can tune circuits to achieve what you want to achieve. For today's exercise, if you look at this, we have a result at 2.7. That's what we want to achieve. And that has been achieved. You can see now that this circuit has center frequency. This bumpers filter now has a center frequency of 2.7 gigahertz. Now, the next thing you need to do is to populate this result, because right now the values I have here 25.102 and of 51.444 is yet to populate onto the circuit. So for us to have that value on the circuit, we need to we need to populate that result. So how do we do that? If you look here, you look at this point, it says update schematic. As soon as you click the update schematic button, you realize that the values you have here will replace the current values we have in our circuit. So I'm just going to click on update schematic, and now I can close this window. Do you want to exit tuning? I will say yes, and then I can close this window. And now you see that the values we had previously have been changed. And also notice that there's a T in front of the value. Just this T here is just to indicate that this value was achieved by tuning. So this is not the actual calculated value, but the value we achieved by tuning. So this is it's a very simple thing to do. You just need to use the tuning button here, and then arrange your circuit so that you have both the data display window and the schematic window in view. Then you can tune and achieve whatever results you target to achieve. Now all I need to do now is to save this, and close the window. And of course you can also close data display window. Now if you go back to your ADS workspace, if you open the schematic window, you see that it's been updated. So we don't have the previous value anymore. It has been replaced with the tuned value. You can also open the results. You notice also that the center frequency is now at 2.7 gigahertz instead of the previous 2.6 gigahertz. So that's basically our target. We've achieved it.